In this video I'm going to show you how you can use calculus to sketch graphs. So we've been asked to sketch this graph. We have no idea what it looks like. So our normal routine would be to insert 0, 1 and -1. See where it jumps to. So when you put 0 into here, it would be e to the power of 0 over 0. And you're not allowed to divide by 0. So it breaks down. When you insert 0 in there, it breaks down. You shouldn't be inserting 0 in the first place. So we know there's some sort of gap dead on 0. Let's insert 1. Put 1 into here, so that would be e to the power 1 over 1, which is e to the power of 1, which is just e. So it's roughly 2.7 something, so it will jump to somewhere around here. When you insert -1 into here and into here, it will give you e to the power -1 over -1, which is the same as e to the power of -1, which is -1 over e. So that's -1/3-ish. So it's going to be somewhere around here. So we know it passes through here and here. So far we know it passes through roughly 2.7-ish and -1 over 2.7-ish. We know it passes through here and here. We know there's a gap dead on 0. So now let's investigate what happens when x is very, very large. Let's imagine 1000. So we are trying to work out what happens to the right hand side of the graph as x moves to positive infinity. So as x moves all the way to the right. So really we're trying to investigate the limit of this thing as x heads towards infinity. So imagine a very, very big number. So that would be e to the power of very, very big divided by very, very big. So the question is which one would be bigger, the numerator or the denominator? Oh, okay, if 1000 is not big enough, let's imagine we're moving towards 1 million. So that would be this thing here, 1 million. You see, I know e is 2.7 something. Let's just imagine it's 3. 3 to the power of 1 million divided by 1 million, which would be bigger? Well, if you think about it, the numerator would be a lot bigger than the denominator. For example, 3 to the power of 1000 would be bigger than the number 1000 itself. So if the numerator is bigger than the denominator, well, if this is going to be so much bigger than this one here, so you know it's going to head towards infinity. So the limit here is actually infinity. So you know when it's very, very, very big, then it's going to head towards infinity. It's going to get bigger and bigger and bigger, so it's heading upwards. And let's investigate what happens when x heads towards negative infinity. So when x is moving all the way to the left. So let's imagine -1000. So -1000, that would be e to the power of -1000 divided by -1000. I have the right to move the negative up here, and I have the right to move the negative out here. So we can just concentrate on analyzing this bit only. So we've got a negative, whatever this may be. So now we don't understand what it means to have a power of a negative. So let's jump to 1 over e to the power of 1000 divided by this thing here, 1000. Don't forget this whole thing here has a negative in front of it. So now you've got a fraction, and then you're dividing by a whole number, so it gets multiplied to the bottom. So that will then give you -1 over 1000 times e to the power of 1000. So this is going to be big times 1000, so the denominator is going to be very, very big. Well, 1 divided by a very, very big number, overall it would be very, 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 very small, and there's a negative in front of it. So it would be a very very small number, a negative small number. So what that means is, in your mind, picture -0.00000, let's say 6, say. So it's going to be a very, very small number with a negative in front of it. So what that means is the graph will look something like this. Very, very small. And, well, here we can say that the limit is actually 0 because it is heading towards 0. And it's heading towards 0 from the negative side. So we know it's less than 0. So we know the graph will look like this. Okay, so far we know that when x is very, very big, it's like this. When x is negatively big, it will look like this. So far we know this. So far we know that it looks like this and like this. It must pass through here, it must pass through here. There's a gap dead on 0. So now let's investigate. Well, we know dead on 0 breaks down. So let's investigate what happens just to the right of 0. A microscopic amount just to the right of 0. So we are trying to work out. We suspect it may look something like this, I don't know, but what happens as you head towards 0? Is it going to be all the way up here, or is it going to head towards 0, or is it going to head towards negative big? So we need to investigate what happens just to the right of 0. Well, just to the right of 0, we could select a really small number like this, 3 say. But just to the right of 0, I'm going to select 1 over 1000, which is a small number. So let's put this into here and into here. So that would be e to the power 1 over 1000 over 1 over 1000. Hang on, let me think. So you've got a number here divided by a fraction here. So that's like a number here, e to the power 1000 divided by this number here, 1 over 1000. That's the same as e 1 over 1000 times 1000 times the reciprocal of this. So that becomes this 1000 times e to the power of 1 over 1000. So let's well, you got 2 blocks here. Let's see what happens. Hang on, let me clean this up. So remember, we are looking at just to the right of 0. Just to the right of 0 right here at 1 over 1000. What is this block here? Well, if you look at y equals e to the power of x, just to the right of 0, well, remember this is 1. Just to the right of 0 is going to be 1 point, a really small number above 1. Let's just imagine this. Just to the left of 0 is going to be below 1. So let's just imagine 9998, say. So this block here is slightly above 1. So imagine that this block here as being like this. So you've got a 1 point something times very, very big. So it means that just to the right of 0, it jumps up to 1000. And then if you don't want to use 1 over 1000, if you use 1 over 1 million, then it turns out to be just slightly above 1 times 1 million, which means it's going to jump even higher up here, up there somewhere. So the point is, just to the right of 0, it's going to be very, very big. So you have a hunch that it's going to look something like this. I don't know. It's going to look something like this, because it must shoot all the way up here. It must shoot all the way up. Okay, so we know it's going to be very, very big just to the right of 0. Now let's investigate what happens just to the left of 0. So just to the left of 0 is going to be negative 1 over, let's say, 1000. So let's put this into here and into here. So we are trying to work out the limit as x heads towards 0 from the left hand side, from the negative. Okay, so we are trying to figure out what happens as x approaches 0 from the left hand side. So put here it's negative 1 over 1000. put this into here, so that would be e to the power of negative 1 over 1000 divided by negative 1 over 1000. So I'm going to move the negative up here. I'm going to now take it out here, so it will look like this. I can just concentrate on evaluating this. So that's the same as negative, that's this negative here, e to the power negative 1 over 1000 divided by 1 over 1000, which is the same as me multiplying by 1000. So that equals negative 1000 times e to the power of negative 1 over 1000. Now let's try and understand this block here. Well, if you look at the graph, hang on. If you look at the graph e to the power of x, it looks like this. Equals e to the power of x. Just to the left of 0, this is negative 1 over 1000. Just to the left of 0, this block here will be, well, this is 1 here, so it will be slightly smaller than 1. So imagine this to be 0.99968, I don't care. It's just going to be just below 1. So just below 1 times 1000 is going to be very, very big, and it's negative big. So you know it's going to jump somewhere down here. So just to the right of 0 is going to be very, very big. Just to the left of 0 is going to be negative big, because you've got a negative here. It's going to be negative big. It must pass through here. It must head towards 0. So we can guess it looks something like this, or maybe it might do something like this, and then it could do something like this. So our graph, well, we know that this must be true. It must pass through here. It must be very, very big. It must be very, very negative big. It must pass through here. This could be wrong. This must be right. This could be wrong. So I will continue in the next video. We need to investigate further, because it could do something like this. It could wobble somewhere around here. I will continue in the next video. Okay. So far, sorry, hang on. So far we know that it must do this, this, and so on. In the next video, we're going to investigate dy by dx to get an insight into what's going on. It could do something like this. It could do something like this. Okay? Next video.